Good morning. Today I'm going to talk about a scientist named Alfred Wegener and his hypothesis of continental drift, this idea that he had. And he's not the first to have this idea, but he was the first to really start putting evidence together about this idea. And he was a German scientist that proposed that the continents used to be in different places. And somehow they have moved from where they were to where they currently are. So again, this is called continental drift. And it's a very important idea in earth science. It's going to be what will lead to all of our other understandings of earth science, earthquakes, volcanoes, etc. And what he noticed, which a lot of people had noticed even before him, was that if you rearrange the continents, like if you take a map and you just cut it into pieces, continents. If you just rearrange them, you can put them together like puzzle pieces, especially when you look at North America, South America, and Africa. It's really uncanny how well those coastlines fit together. And even since early map makers, they noticed this, but most people just assumed it was coincidence, okay? But like I said, Wegener was a scientist, and he started to collect evidence that showed that they probably did fit together at one time. The first thing he looked at was fossils. Fossils have been found for hundreds of years, thousands of years really. But this idea of paleontology, of looking at fossils as previous forms of living species, was relatively new. And when he started looking at these fossils, what he noticed was that you could find an individual species all over the world. And there's a few examples in this picture. So 1, 2, 3, 4, 5 different types of fossils here. And like this land mammal, or not mammal, this land creature, probably some kind of dinosaur or dinosaur relative, which has small legs, is not aquatic, doesn't swim. You can find it in North America, South America, Africa, even in Asia. And he hypothesized, well, okay, this thing didn't swim across oceans, so how did it get to all these continents? And he did the same thing for many other types of fossils, okay? Found that they were like widely separated presently throughout the world. Again, taking the pieces of the continents and putting them together, what he found was that the distribution of these fossils, like where in the world you find these fossils, actually makes a lot of sense once you put the continents back together. Like puzzle pieces. And we see that in this image here, where this fossil, this creature, its range is all this area, partly in South America, partly in Africa. Well, it wasn't swimming across thousands of miles of ocean, but if those continents were together at one time, then it simply walked from one region to another. There wouldn't have been an ocean there. And he found this with many, many different types of fossils, that their ranges made a lot of sense once you put these continents together. Okay. So besides fossils and fossil distribution, we also can look at, or Wegener looked at, climate evidence. Now, by climate evidence, what he was looking at, and we have better ways of looking at this now, but what he was looking at was geology of certain regions that showed evidence of massive glaciers. Glaciers, especially big glaciers from the past, are easy to find because they scour away rock and they scrape all these indentations into surface rock. So looking for evidence of past glaciers or paleoglaciers is actually fairly easy. We do this in North America all the time, in New York, in Michigan. You can see it on rocks, the past evidence of glaciers. And he found signs of glaciers in areas that are far too hot today to have glaciers. India is the best example up here. India, no way does it get glaciers. Up in the Himalayan mountains, it does. But the continent of India is way too hot to ever get glaciers. Same thing with South Africa and Southern Australia. But if all of these continents were smashed together down here near the South Pole at one time, then it makes sense. And again, the range overlaps once you put them all back together. All right, more rock sample evidence. This is looking at rock types, and we can tell by looking at samples of rocks if one rock in one location is the same as another rock maybe 100 miles away. So what that means is we started looking at rock samples in various mountain ranges. And many of these mountains that are separated now by oceans, they're on different continents. Once you actually examine the rock composition, it's shown that they were once part of the same connected mountain range. And in this image here, what you see are North America and Europe. And these are much closer than they actually are today. But you have the Appalachian Mountain Range that runs along the east coast of North America, up here into Greenland. And then when you bring everything close together, you see the same rock types here in Britain, Ireland, along the west coast of Africa, and this mountain range here in, let's see, is that Norway? I think. The Caledonian Mountains. These are all the same rock type, and they were all connected at one point in the past. Now they're separated by thousands of miles of ocean. So he didn't understand what the mechanism, he didn't understand how this was happening. He just collected the evidence saying that it did happen, that continents moved. But at this point, we don't know why or how it works. That will come later. All right, thank you.